Okay, Foundations of Math 20, this is 7.7. Guys, quadratic formula. This is super, super important. So you guys are in grade 10 here now. So as you move through grade 11, grade 12, university, you're going to be using this. Anytime you do math, you'll be using this. Very important formula. And of course, we've been talking about quadratic equations and parabolas. And this is going to help us find solutions to quadratic equations, or the roots or the x-intercepts to quadratic functions that we're going to graph. So the quadratic formula, let me just read a little bit about this, and then I'll explain kind of how this works a bit. So the quadratic formula is a formula for determining the roots, like I said, of a quadratic equation, so the solutions. The quadratic formula is written using the coefficients of the variables and the constant of the quadratic equation. So in the standard form, you'll recall that the coefficient on the x squared is a, the coefficient on the x term is b, and the constant is c. So we're going to need those values to use in the quadratic formula. So if you have an equation that's in the vertex graphing form and you don't see a, b, and c, you won't be able to use it just using the numbers that you see there. So you might have to do a little rearranging. For example, oh, come on now. So if you have like this one, right? Remember we just learned this one? Okay, if it's in this form, you can see A, but B is like, what's B? And is this really C? Well, not necessarily. So it's usually when it's in standard form, here we go. Good time for the phone to ring and my computer to crash. Okay, so yeah, we're looking for, in standard form, if you have A, B, and C, you pump it into this formula and you're going to get the roots. So this is it right here. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I do have a song for this that will help you remember this formula. And I've had students in tests going, like this, and so the song is catchy. I'll play it for you a little bit later, okay? But anyways, how does this come about? Well, this is the one way that I like to kind of show this is, do you remember this? So if you recall, x equals negative b over 2a. Do you remember what that gives us when we plug in the a value and the b value from a standard form? What does this give us? X equals, what is that? It's the axis of symmetry. Very good. So if we have a parabola, that's a crooked line. Straighten this up. So if we have a parabola, okay, and I have a parabola that looks like this, let's say, okay, this x equals negative b over 2a will give us the yeah, go ahead and watch my YouTube shorts if you like. There's a little plug for that. Okay, let me do this again. So if you have a parabola, my greatest lesson of all time interrupted by computer problems. So x equals negative b over 2a gives you the axis of symmetry, okay, right here. So that is the vertical line that contains the vertex. Now, watch this. It's this quadratic formula. It will tell you what this point is and what this point is. Okay, it'll give you the x values of those points. Now, if you consider this as the axis of symmetry, if you use a and b and c now, the quadratic formula will be able to tell you how far from the very middle of the parabola you have to go to get the x value that is the root. So it's like if you add a certain amount and subtract a certain amount from the x value there, then you will get the roots. So if I take negative b over 2a and I add something to that, then I will get this x value. And if I subtract something from this, I will get this x value. And it just so happens that this quantity that we add or subtract looks like this. It looks like the square root of b squared minus 4ac over 2a. Okay, and this, now you don't have to know why this is for now, But this is the way I like to try and explain this, is that you have the axis of axis of symmetry, and you add a certain amount to it to get this root over here, and then you subtract a certain amount to it to get this root, and it happens to be the same amount because it's symmetrical, and that's how you can find the roots. Now, if we put this together, okay, we put this all together, okay, and I'll erase this now. So mathematically, if I put this together, I have a common denominator, so I can just write this as x equals negative b plus or minus the square root. My computer is sleeping. It's not ready for this math today. All over 2a, because that's how you add fractions that have a common denominator. Okay? So think about axis of symmetry, plus or minus a certain amount will give you the roots. And depending on what a is, what b is, what c is, that's how much you add or subtract from that axis of symmetry. Okay? So that's just a brief explanation of why this is. Do you have any questions for me right now?
So why this?
Okay, so I'm not going to explain why this part looks exactly the way it does, but we are going to explore features of this quadratic formula. So I'm not going to give you any more explanation of why they came about with this value, but we are instead now going to focus on how to use this. Okay, so if you have a question on why that is, let's talk later. Okay, but not in this lesson. Okay, now using the quadratic formula, let's do an example. Please write this down. This quadratic equation is fairly easy to factor and to find the roots using the zero product principle. And we've done this before, so I will do this with you, okay? Let me just squish that up so you can see that. So on the left side, I'm going to factor this. And remember, it's a quadratic, a trinomial, so I'm going to try to factor this into two binomials. This is just x squared, so this is x and this is x. Now I need two numbers that multiply to 10 and add to 7. What are those two numbers?
5 and 2.
Very good. So plus 5 and plus 2. Now the solutions are x equals negative 5 from this first factor, and x equals negative 2 from this factor. All right. Now let's use our new friend, the quadratic formula. And that, of course, is x equals negative b plus or minus root b squared minus 4ac all over 2a. Or think about it this way. Ready? X equals negative b plus or minus root b squared minus 4ac all over 2a. Dum dum dum, x equals negative b plus or minus root b squared minus 4ac all over 2a. So there's a song. I'll play the song a little bit later, but that's the song, and that's going to help you remember the quadratic formula. Hey? Yeah, singing. That's right. All right, x equals. So what is the b value? B is positive 7. A is 1, and C is 10. So negative b is going to be negative 7. And I'm going to add and subtract a certain amount over here, which is going to be b squared. That's going to be 7 squared. And if it's a negative, you have to square the whole negative. So just make sure you remember that's all in brackets there. Minus 4 times a is 1, and c is 10. Okay. All over 2 times a is 1. All right, now that's the first step of just putting in the values, okay? Now it might look like, whoa, wait a minute, that looks really confusing. But if you just simply, simplify things using order of operations, you will find that this actually is not going to be too bad. So watch what I'm going to do here. Inside this root sign, I am going to evaluate all of this. This is going to be 49 minus 40 all over 2, okay? And you'll be able to do some of this in your head, but I'm just showing every step, doing the long way. So this is going to be what? Root 49 minus 40 is? 9 over 2. Well, this is really handy because root 9 can be simplified, right? So that's going to be negative 7 plus or minus 3 over 2. Wow. So that's going to be x equals negative 7 plus 3 over 2 and negative 7 minus 3 over 2. Those two values are going to be negative 4 over 2 and negative 10 over 2. Or x equals negative 2 and negative 5. And I've got way too much on my screen right now. All right, so initial thoughts on this. Let's hear you. What are the initial thoughts?
I just have a question.
Question.
From 9 over 2, did you, you said root 9 could be simplified?
Yes, the square root of 9.
So you didn't divide it by 2?
Okay, so, oops, zoom in. So root, okay, so yes, I'm dividing it by 2, but I'm not doing the root 9 itself divided by 2. You see, this is all over 2. So order of operations, really, you would do this addition, subtraction first before you did the multiplication. So you could rewrite it like this, if you want, like negative 7 over 2 plus or minus root 9 over 2. You could rewrite it like that if you want. But you're going to be adding fractions and stuff. So I would encourage you to evaluate the top first and then do your dividing. Yeah. Especially if it's a perfect square, like 9 is a perfect square. So that's the radical, the root sign is going to be gone. So that's going to be awesome. Okay. So that's the first look at the quadratic formula, and you get to the same answers. This one is super easy to factor, so you might want to factor this type of question instead of using the quadratic formula, but there's going to be lots of situations where the quadratic formula is going to be the only option. So let's take a look at some situations that we might run into and how the quadratic formula and a specific part of the quadratic formula will be very helpful for us. Okay, so in the quadratic formula, x equals negative b plus or minus root b squared minus 4ac all over 2a. Okay? Now, this part right here will tell us a lot about the roots of the equation or the x-intercepts of the parabola. This is very important. So I want to go over just what this tells us. All right? So you might want to write this down in your notes. If b squared minus 4ac, and there's actually a name for it which you don't need to know right now, but I will talk a little bit more about that in upper math classes. But anyone know?
Data.
Huh?
Data.
Data?
Like, with
Oh, delta? No, not quite. It's the discriminant. It's the discriminant. And you don't have to know that, but discriminant.
We used to call it delta.
Have you heard about this before?
Yeah, didn't we get shown it last semester to find out if a factor was prime?
Yeah.
To find out if a factor was...
Sorry,
No.
find out if an equation was prime for like linear equations. I think we got shown that.
No.
No, not quite. No, I don't think you've seen this one before, but that's okay. So this is the discriminant. Now, it's because it discriminates against, it helps you identify the nature of the roots, okay? So if b squared minus 4ac is less than 0, that means it's negative, then there are no solutions. So let me just show you.
No real solutions.
Let me just show you. So b squared minus 4ac, guys. Dammy, go shut that door, please. Dammy, go shut that door. B squared is 4 squared here, minus 4 times 2 times 10. So that is 16 minus 80. So that's going to be negative what? 64. So if this is negative, that tells us that we have a problem, okay? Because look, if this value underneath a square root sign is negative, that means the calculator will show just error. It's not possible. You can't take the square root of a negative number. That's one of the rules in math. Because when you square a number, it always ends up to be positive. Doesn't matter if the number is negative or positive to begin with. If you square it, the answer is always positive. So you can only go from a positive and take the square root. You can't go from a negative and take the square root. It doesn't make sense. So what does this look like when we graph this? I'm going to graph this equation for you. And I've actually got it already done here on Desmos. So I think this is the first one. Okay, now look at this. I'll zoom in. Notice how this parabola is hanging above the x-axis, which means there's no x-intercepts, which means there are no roots. If the parabola does not contact the x-intercepts, that means there are no roots. So the discriminant here has told us that there are no roots. And I think I have the graph over here. Here we go. I'll bring that into our notes here now. So this is what the graph looks like. So you can put it all together on one screen, okay? So if you get a negative underneath the square root sign when you're using the quadratic formula, no roots. No real roots anyways. And we're not going to talk about unreal roots or complex roots. We're not going to talk about that. But there are no real solutions. So for you guys, there's no roots at all, okay? So there's no solutions. All right, number 2. What happens if b squared minus 4ac, the discriminant, equals 0, okay? If it equals 0, then what happens there? Well, here's an example where we're going to have this equaling 0. So b squared minus 4ac is actually negative 10 squared minus 4 times 1 times 25, which is positive 100 when you square a negative, minus 100. So that equals 0. In this case, you have one root, or like I mentioned before, technically 2 identical roots, but we'll just call it 1 root for now. That means that this parabola is just going to bend down and touch the x-axis just once. And so let's see on Desmos what that one looks like. Oh, there we go. Look at this. Okay, 5, 0 is our one single root. It touches the x-axis just once. That's what that looks like. Okay, and I think I've got a copy of that graph over here. Oh, let's grab this and bring it in. Okay, whoops. All right, that's the graph there. 1 root. Okay, and if you think about the quadratic formula, x equals negative b plus or minus root b squared minus 4ac all over 2a. So if this is 0, right here, we're adding 0 to the axis of symmetry, and we're subtracting 0 to the axis of symmetry. So that means that the axis of symmetry is right on the vertex is right on the x-axis, because we add 0 to get to the roots on either side. Does that make sense? Okay. All right, let's see a third case here. What happens if the discriminant, b squared minus 4ac, is greater than 0? And that would be the case over here. Let's just see. So b is 1, that's squared, minus 4 times 3 times negative 12. Now you might think, oh, 1 minus this big number. Well, got to be careful. This is actually subtracting a negative, right? So that's actually plus 144. So this is equal to 145. If you have a positive number underneath the root sign, then there are always going to be 2 distinct roots. 2 distinct roots. And yeah, because this number is so high, you might have, the graph might be really stretched or really wide or something. But let's see what this one looks like. So the 3x squared one, okay, that's this one right here. There's the graph right there. And as you can tell, there are 2 roots. They're not integers, they're not whole numbers, right? They're decimals. Whoopsie. They're decimals, so that's not going to be easy to factor. You can't factor that by sight. The only way you're going to get to these solutions is using now the quadratic formula. So many quadratic equations are like this now. Okay, and here's that graph over here. I'll show you that one. Okay, any questions so far? Is this kind of making sense a little bit? Okay. All right, the last one. Okay, now this one is similar to one we've already talked about, but if b squared minus 4ac is a positive perfect square, okay, and I should maybe just write that down. A positive perfect square. What that means is that there are going to be, there's going to be 2 solutions, and that would mean that this could be easily factored. okay, to an integer or to a fraction. So I put this one in. I don't normally talk about this, but if this is a perfect square, then you might want to factor this by sight or factor it another way. I mean, it doesn't matter. You've already done b squared minus 4ac. You already know what that number is, so it's like you can continue on with the quadratic formula. But that means that it's going to be maybe easier to factor. Okay, so b squared, that's negative 13 squared minus 4 times 1 times c, which is 30 in this case. So this is going to be 169 minus 120, and that's going to be 49. So if it's a perfect square, like our first example, the square root is going to be gone, and that's going to simplify to a regular old number, which means you're going to either have an integer or a fraction. And of course, I could factor this pretty easily. Again, two numbers that multiply to 30 add to negative 13, minus 3, and minus 10, right? So that means that this can be factored probably pretty easily. Okay? All right. Any questions? All right, let's do some examples using the quadratic formula on questions that we have already done using factoring. All right, so I'll use a different color here. I'll use red. How about red? Okay, so here's the original equation. Let's take a look at this original equation we're asked to solve. Now we were able to solve this by factoring to get everything over to one side equals 0 on the other side. And then we looked for numbers that multiplied to the first term and multiplied to the last term in the proper combinations to get two binomials. Then we let each factor equal 0 to solve. So this is done in the previous lesson. So let's see, x equals negative b plus or minus root b squared minus 4ac all over 2a. Okay, so there's the formula for finding the roots of an equation. Now, as long as we've got equals 0 here, and this is in standard form, I know that a equals 12, b equals 25, and c equals negative 7. So let's see if we can get to the same answers. So negative 25 is our b, plus or minus the square root of 25 is b, again, squared, minus 4 times a is 12, and c is negative 7. Okay, so I don't know if you can see that. Divided by 2 times 12, okay, which is a, right? Okay, so now that's all we need. We just need to evaluate this now. So negative 25 plus or minus. What is this underneath the radical sign here, the square root sign? Let's get the calculator out. 25 squared, we can do, I think that's 625 minus 4 times 12 times negative 7. So we'll see what that ends up to be. And that's probably going to be some kind of perfect square. Let me just see why my calculator's not firing up here. So let's do this on the calculator. We'll just do the discriminant. Remember, that's the D discriminant. So let's try that. So 25, that's better. 25 squared minus, now this is minus 4 times 12 times negative 7. Okay? So it's actually plus 4 times 12 times 7, right? Because it's negative and negative. But let's do minus. So we'll do 4 times 12 times, I think I can do this, negative 7 without a bracket there. I think that should be good. What is this? Okay, so that comes to 961. So that's actually 25 squared plus 4 times 12 times 7, right? And so let's see, it's squared. Let's see if that's a perfect square. Square root of 961. Whoa, 31. Look at that. You see that? So this is actually right here. This right here is actually 31. Okay? Over 2 times 12 is 24. Now, watch this. Negative 12, or negative 25, sorry, plus 31 over 24. That's going to be one answer. And negative 25 minus 31 over 24 is our second answer. So let's see. This is going to be negative 25 plus 31 is positive, was that 6? 6 over 24. And over here, this is negative 56 over 24. So if I reduce these fractions, look at what I get. That's 1 over 4 and this is negative. Both these could be divided by 8. That's going to be 7 times. And over here, going to be 3 times. And notice that we get the same answers as before. Okay, so there's your 2 different ways of solving that. And you might like the factoring method. I do too. If I have a chance to try and factor, I'll try and factor. Is factoring going to be fruitless? Is it able to be factored? Well, you could check your b squared minus 4ac right away. And we know that this b squared minus 4ac was a perfect square. We saw that was, what, 961? Right? Where is our? Yeah, 961, which is a perfect square. So that's 31 squared. So you know it can be factored. Okay, let's do one more example before we move on to 7.8. It's a combined lesson today. So one more example. Okay, so here we go. I've got 5x squared plus 6x plus 1. I know I can factor it. Here is my calculated roots. So let's do x equals negative b plus or minus root b squared minus 4ac all over 2a. So that's going to be negative b, which is negative 6, plus or minus the square root of 6 squared minus 4 times a is 5, and c is 1. All over 2 times a is 5. So this is going to be negative 6 plus or minus the square root of, this is going to be 36 minus 20. So what's 36 minus 20? That's going to be 16. Woo, perfect square, baby. That's looking really good. So I've got now, notice, negative 6 plus, what's root 16? 4. Beauty, over 10. And the other answer would be the minus part, so negative 6 minus 4 over 10. So that's going to be negative 6 plus 4 is negative 2 over 10. This one is negative 10 over 10. Or my answers would be x equals negative 1/5 and negative 1. Those answers look very much the same as these ones. Okay? So you might say, oh, the quadratic formula is a lot more work, which I get it. For these ones, it would be a lot more work. If you can factor them by sight, or even through decomposition, if you can factor and solve, great. But when you have something like, that's really strange, like a, well, let me just give you one quick example, okay? So let's say I have 0 equals, 2x squared minus 7x plus 5. Okay, now I don't think that it's really easy for us to get this factored. Maybe I'm wrong, but I just pulled it out of my hat here. So let's see. So x equals negative b is positive 7 because it's negative 7. Square root b squared is negative 7 squared minus 4 times 2 times 5 all over 2 times 2. So if this is not a perfect square, that's 49 minus 40. Oh shoot, it is a perfect square. Okay, so this one can be factored. Well, there we go, I guess. I try and make up one that's hard and I end up making one that's easy, right? Am I right? This is 49 minus, which is 8 times 5 is 40. Dad blasted. Okay, let's erase the tape. Okay, forget I said that. The C is now going to be 3. Let's see if that one works. Okay, bet you that's going to be tougher. Okay, so this one here, let's see, 7 plus or minus. Now, this you can, we can now write the roots as exact values instead of changing to decimals. So what's this one going to be? So I said this is 49 minus, what's this? 8 times 3 minus 24. That's going to be a perfect square too. 49 minus 24, that's 25, isn't it? For crying out loud. I am shocked. Try one more time to make this more difficult. I'm sorry. Everything I do is easy. Why is that? 1? Huh? Let's see if 1 works. Goodness. Okay. 1. 49 minus 8. What's that? 41. Not a perfect square. Thank you. Finally. My gosh. Okay. Okay. Try to make something hard. This is root. Okay, watch this. Root 41. See? 49 minus 8, 41. Over 4. Now, you would never be able to factor this one very easily because the solutions are not integral. They're not positive or negative whole numbers or fractions. It's going to be a radical. So look at the two answers are, are you ready for this? 7 plus root 41 over 4 and 7 minus root 41 over 4. And you leave them like this. That's the exact values. See, that's exact. You could change this into a decimal and have it be an approximate decimal answer, yes. But this is where the quadratic formula comes in handy, because when you have something that's not easily factored. Okay. All right, you ready? Let's move on to 7.8. I'm going to do a couple examples here. Okay, so 7.8, now we're going to be using the quadratic formula here, but we're going to be talking about word problems that are quadratic in nature too, okay? So this is what 7.8 is, and like I say, I'll just give you we'll talk about this one right here. This is what the questions are going to be like. Okay, let's read this carefully now. It says, determine 3 consecutive odd integers. 3 consecutive odd integers, okay, so there's 3. Consecutive means one after the other, and they're odd integers, so they're 2 apart. One is going to be the first odd one, and then we got to skip 2, and then plus 2 is the next one. Okay, so let's stop right there. So these 3 consecutive odd integers, I'm just going to let x be the first odd integer. Okay, I got to start somewhere. I can just let x be the first number. Now all of the other numbers have to be related to this x. Okay, so x plus 2, guess what that is? That's the second odd integer. Okay, and then the third one would be x plus 4. The third, okay, odd integer in a row. Okay, so here we go. I've got the 3. I've got them set up right now. This is beautiful. Okay, I've got algebraic expressions for each of these. That's what you want to do. You want to define your variable and then try and write the other things in the question, like in this case the other odd integers, in relation to that one. So you have one variable, but you have kind of 2 or 3 or 4 different things expressed. Okay, so now this is where it gets kind of tough. Ready? The square of the largest integer, okay, that's this one, the largest one, is 33 less than the sum of the squares of the 2 smaller ones. Okay, this is where it gets tricky. It just gets tricky. Okay, so this one, the square of the largest, okay, I know what the square of the largest is. That's x plus 4 squared. Okay, now that is compared to, it's actually 33 less than. So think about this. This one is smaller by 33. So if I'm going to make an equality here, okay, between this one and I'm just wait for the 33. The sum of the squares of the other two are on the other side. So x squared plus x plus 2 squared. That's where the other two are on the other side. Okay. Now this one is less. It's 33 less than these guys, than this sum over here. So if I want to make them equal, which one do I have to add 33 to? Okay. So I have to add 33 to the smaller one. That's the square of the largest integer, is less than these other guys. So I got to add 33 over here. Okay. Now just sit and think about that for a second. All right. Think it through in your mind. Here's my integers. And yes, you can just let x be the first one. Just this is my first number, because all of the others are related to x. So the square of the largest one, this is the largest one, here's the square of the largest one, is 33 less than what? The sum, here's the sum of the other two numbers squared, okay? The squares of the other two ones. So in order to make them equal, I have to add 33 to the smaller one. So just make sure that that makes sense in your mind right now. Any questions? Okay, someone had a question. Could I subtract 33 from the bigger one? Absolutely, go for it. Yes. I usually like adding instead of subtracting myself. So that's why I chose that one. But yes, you could do subtract 33 on the other side to the big one. Perfect. Yeah. Okay. So, all right, now what we have to do, this is looking good. We have to expand, multiply out, gather all the like terms, get everything over to one side. Just like we do with all the other ones that we've done the last week we've been doing this. So I'm going to do x squared, I'm going to expand this out right here, x squared plus 8x plus 16. If you don't believe me, write it out and multiply it out using the FOIL method. Plus 33 equals x squared plus 4x plus 4. That's this one expanded out. Okay? All right, I got lots of like terms I can gather. Well, actually, these x squareds are both the exact same on the axis, so they actually cancel each other out to be 0, right? So I'm left with 1x squared over here. I'm going to keep that over here. It's nice and positive. I like the positive number in front, so I'm going to leave it on that side. I'm going to bring the 8. I'm going to bring everything else over to the other side now. Okay, this is all going to go over to the other side. So I'm going to subtract 8x. I'm going to subtract 16. I'm going to subtract 33. Okay, to get them off of this side. This is going to be 0 now. And now I have these that are still left over there, right? That one that I've written down already. Plus 4x is still over here, and then plus 4. Okay. So when I gather all the like terms, what do I end up with? I end up with x squared, all my x terms, so negative 8 plus 4x. What's that? Minus 4x. Negative 16 minus 33 is what? 49 plus 4, so negative 49, negative 45. Okay. And now I can, okay, everybody good with that? I think we're on the right track here. So I have two options now to solve this, right? You have lots of options. We can graph it and find the x-intercepts on the graph. Boom. You can factor this. It looks like I think you can factor this and use zero product principle. Boom, that's number 2. Or you could use quadratic formula. Since we've learned and we've met a new friend in the quadratic formula, let's use the quadratic formula, shall we? Okay. So let's see what these roots are going to look like with quad formula here. Come on now, Nelly. So x equals negative b, that's negative 4, plus or minus the square root of b squared, negative 4 squared, minus 4 times a is 1 times c is negative 45. All over 2 times a is 1. So x equals positive 4 plus or minus. Now what is this in here? This is the discriminant, remember? So we've got 16, and then we've got 2 minuses, so that's plus 16 plus 4 times 45. Well, what's 4 times 45 is the same as 2 times 90. Okay, 4 times 45 is the same as 2 times 90, which is 180. So I've got, I'll just write this down, 16 plus 180. Yep, over 2. Okay, so moving up over here, I've got 4 plus or minus the square root of, that looks to be 196. Awesome, over 2. X equals. Okay, so what's the square root of 196? Any guesses? Yep, square root of 196 is 14. So this is going to be, I don't need to write that square root. This is going to be 14. And see, because that's a perfect square right here, I know I can probably factor this fairly easily. Remember that? And so you're going to see how I'm going to have 4 plus 14 over 2, and I'm going to have 4 minus 14 over 2. So x is going to be equal to 18 over 2, which is 9, and negative 10 over 2, which is negative 5. Okay, those are my solutions. Now, okay, so now, 2 things. One thing, yes, you could have done this by factoring, and I am going to show you that right now real quick. Okay, I'm going to get rid of all this. How could you factor that? Well, you're looking for 2 numbers that multiply to negative 45 and add up to negative 4. And of course, that could look like, and I'll write it over here, x minus 9 times x plus 5. See, that multiplies here and adds to that. And so we have x equals positive 9 and negative 5 as answers. So you get those solutions both ways. That's the first thing. The second thing is, because this is a word problem, remember what I said earlier in the lesson, that from here down, right, the math does not know what the question is. So we have to double check our answers that the math gives us and see if those are both reasonable. So see if these qualify as possible answers. Now, 3 consecutive odd integers. Remember what we let x equal? X was the first odd integer. So let's say that x is 9. Then I have 3 consecutive odd integers of 9, 11, and 13. You see that? And if negative 5 was the first odd integer, I have negative 5. The next one up is -3. The next one up is -1. You see that? Odd, odd. Okay. Boy. Those are two possible solution sets now, given that x could be two numbers. Now let's just check to make sure. Determine 3 consecutive odd integers. Okay, these are consecutive. They're odd. The square of the largest is 33 less than the square of the sums of the other two smaller ones. Let's see. Okay, the square of the largest, 13 squared minus 33. Is that equal to 9 squared plus 11 squared? 13 squared is 169, I think. 169 minus 33. This is 81 plus 121. So this is 136. And this... Okay, am I losing it? Okay, yeah, sorry, I wrote this down as this is minus, this is actually plus. So yeah, that, whew, that's good. Yeah, I see it up there now, right. I was thinking about the minus one that I did, but yeah, I did the plus one. So this is not minus, this is, so what's that, 202? This is 202, awesome. Okay, so these ones work. Let's check the other one. Let's check the largest integer is this one now, okay? So this is -1 squared plus 33 is equal to what? -3 squared plus -5 squared? Is that right? So 1 plus 33, 1 plus 33 is 34. And this is 9 plus 25. Oh my goodness. Look at this. That works too. That works too. So in this case, both of these x values are good for our starting number. And then the 3 sets. So there's actually two different answers here. And they are the numbers 9, 11, and 13. And the numbers -5, -3, and -1. Whew. That was a tough one. That was a long question, but that's kind of what 7.8 is like. Okay, and if you can do that, if you feel somewhat comfortable with that, whew, you're doing great. Okay, this is big kid math here. This is nothing to sneeze at here. This is big kid math. Okay, all right. I'm going to end the lesson here, but there's some other word problems that I want you to do. So I will give you your 7 points. What are we at? 7.7, 7.8. Wow, here we are. That's so small. There we go. So here's your 7.7. 7.8 homework. You may have this quiz tomorrow if you're in my class today. If not, this is the assignment. That would be great practice. So number 13 is optional here, not the whole assignment. Number 13 would be optional. And yeah, and then your review assignment, we're going to have a quiz coming up, and we're going to have a test coming up shortly after that, chapter 7. Hey, bye.